Welcome to our YouTube channel eLearners 365. So today's topic is Python Oops. We'll see what is class, what are objects, polymorphism, encapsulation, inheritance, and data abstraction. Moving ahead, what is class? So class is nothing but a collection of objects. Okay, it is defined as the blueprint or the template from which you can create an individual object. Okay, I'll start with an example. You'll understand it better. For example, I am a builder. Okay, and I want to build buildings on a ground. Okay, in a specified ground. I wouldn't start building directly. I wouldn't start putting the foundation directly until and unless I define a blueprint, I make a prototype or a template. Okay, at least a template on a virtual computer on how my building will look like, how will the infrastructure look like, right? So when I'm doing a blueprint or a template, it is a logical entity. It is not consuming any space on the actual ground for buildings, right? It is just a virtual logical entity. Similarly, when I am writing a code to create objects in my program, I would first start by writing a class. A class is in similar lines. It is just a blueprint or a template for creating my objects. So since it's just a blueprint or a template, it does not occupy or consume any space or memory in my computer. Hence, it is called the logical entity. Okay. Let's see how the syntax looks like. The syntax is you write the class keyword and then the class name colon, and then below that you write the statements of the code inside the class. Moving ahead, we'll see what are objects. Now objects are defined as an instance of a class. Okay, when I say it's an instance of a class, they are real world entity like pen, chair, table, computer, watch, etc. So they are physical entities, and hence they contain an address in my computer, in my memory, and it will take up some space in my memory, right? So the object is basically the real world entity or the instance of a class. An object consists of three main things. What are they? State, behavior, identity. What is state? State is nothing but the attributes of an object. It reflects the properties of an object. Okay. And behavior is nothing but the methods of an object. It reflects the response of an object to other objects. And identity is unique name to an object that we give, and it enables one object to interact with other objects. Let me give you an example. For example, my object name is dog. Okay, so dog is an object. Why am I saying it's an object? Because it does have three things that we have mentioned here. Let's check. So a dog has states like color, name, breed. Okay, so these are all attributes of the properties of a dog. So hence it has state. Okay. So what are behaviors? Behaviors are like wagging the tail, barking, eating, sleeping. These are all behaviors of a dog. Okay, so these will be written as in the form of methods inside an object. Identity is giving a unique name to my object. Let's say Jimmy or Tommy. So all these three things are satisfied, hence my object is a valid object called dog. Okay, let's see how to create an object. It's very simple. You write the object name is equals to the class name, round brackets. Okay, you can, instead of obj, you can give any name. Okay, I can write Jimmy is equals to dog, round brackets. Okay, you can give any name. So object name is equals to dog, the class name, round brackets. Let's see what is init method. It's a very important part that you got to understand. It is, if you've learned C++ and Java, you must have learned what are constructors, right? So constructors are nothing but it is used to initialize objects state. It is basically to initialize and assign values to the data members of the class when an object of the class is created. So like methods, a constructor also contains a collection of statements that are executed at the time of object creation, right? So and it is run as soon as an object of a class is instantiated. Similarly, in Python we use init method instead of similar to constructors. It is also used to initialize. Okay, it is run as soon as an object of a class is instantiated. It is useful to do any initialization you want to do it with your object. We'll see with an example. Let's see creating a class and object with class and instance attributes. So here I have created a class called dog and I'm declaring an attribute is equals to mammal. Okay, and then I'm writing my init method self comma name. Okay, and then self dot name is equals to name. And then I create another method called speak, under which I write print my name is curly brackets dot format self dot name. Now I declare my object. Object name here is Jimmy is equals to the class name dog bracket Jimmy. Okay, and I declare another object, say Tommy is equals to dog brackets Tommy. Now I call the methods. How do I call? You call it by object name dot the method name. So my object name here is Jimmy dot speak. So it will, this Jimmy will get passed on here self dot name and then it prints the whole sentence. So here my whole sentence will be my name is Jimmy. Okay. Similarly for Tommy object name Tommy dot the method name. So my name is Tommy is print. Okay. This is a small example of how you declare a class, an object and init, and how init method is used in between them. Moving ahead, the next concept is inheritance. You must have learned this in school, inheritance. Okay, a parent passes all the attributes like skin color or the attitudes, the characteristics, the character, the hair color, etc. to a child. Okay, so this concept itself is called inheritance. Let's see how this concept is used in writing a program. So when an object acquires all the properties and behaviors of another object, okay, so that whole concept is called inheritance. Okay, so the new class is known as the derived class or child class, and the one whose attributes are acquired is known as a base class or parent class. So basically a parent class gives all its attributes and properties and behaviors to its child class. Why is this used? Why is this concept used in programs? So that it provides code reusability. What do I mean by that? If I'm writing a code, okay, or an object under which I write few methods and I want to use the same methods again in another object, I don't have to keep on writing the whole thing again and again when it is needed. I just call all my attributes from my parent class. Okay, that's where you reuse the code which is already written, and it also reduces the lines of code to be written in a program. So those were the advantages of the concept inheritance. So let's say I have a class called A and I have class B. If class A gives all its properties, behaviors and methods to class B, or let's say vice versa, like if class B is taking all the attributes and behaviors, methods from class A, then in that case class A becomes my parent class and class B becomes my child class. Okay. Let's see an example. I have an example here. I declare a class called person, okay, and then I write init method, okay, name and ID number, and display, okay, display, and then I use those ID number and name, and details maybe we use ID number and name. Now I declare another class called employee. Here I am using bracket person. What do I mean by that? It wants to implement or take some of the properties from the parent class of, here the parent class is person. Okay, so this is how you write if you want to use inheritance class employee and then the parent class name. So here the parent becomes person, the child becomes employee. Here we write init name, ID number, salary, post. Salary, post are the new variables that we are declaring. So we write self.salary, self.post. ID number and name are already been declared inside person. So we just don't have to write self.name, self.id number again over here. We can just write the parent class name dot init and self name ID number. So here my parent class is person. So person dot init method self name ID number. Then we declare another method details and then we print all these name, ID number and post. And then here I'm declaring a variable is equals to employee. I pass all the way variables that is to be passed inside the class. So I write name Jimin, ID number 1310, salary 20,000, post intern. So now I write x dot display. So it is calling the method which is been written inside my parent class, that is person here. So it displays Jimin and 1310, and then it displays x dot details. X dot details, it prints my name is Jimin, ID number and post. So this was a small example of how inheritance is being used here, right? When you call display, display was not written at all inside employee, but it fetched that from the parent class, that is person, and it printed those sentences. Okay, moving ahead, we'll see there are a lot of types of inheritance. Let's see them one by one. If there is a parent and there is a child class, okay, and the child class is inculcating all the properties and behaviors from the parent class, then that kind of parent child class relationship is called simple inheritance. The previous example that we saw, employee and person, okay, that was an example of simple inheritance. If we have two parents and there's one child, and it is inculcating properties and behaviors from both the parents, in this case, this type of inheritance is called multiple inheritance. I have one parent, I have child. This type was simple inheritance, but that child also becomes a parent at one point of time when it gives all its properties and behaviors to the next child class. So we have child class 2 inheriting properties and behaviors from child class 1. Child class 1 inheriting all the properties and behaviors from parent class. This type of inheritance is called multi-level inheritance. Okay. Then we have one parent and two children, and both the children inheriting properties and behaviors from the parent class. Then it is called hierarchical inheritance. Now here you can see there's one parent, okay, and two children, which was similar to hierarchical inheritance. We also have child giving properties and behaviors to the next child. So that is a type of multi-level inheritance. You can see two parents giving their properties and behavior to one child. That is multi-level inheritance. So it is a combination of all these types of inheritance, and hence it is called hybrid inheritance. Okay. Next concept is polymorphism. The word itself is being divided into two words. What are they? Poly and morphism. Poly means many and morphism means forms. So many forms is called polymorphism. Let's see how is this concept implemented in our code. So here I have a code called class bird, and I declared two methods: intro, in which I print there are many types of birds, and flight, with where I print that most of the birds can fly but some cannot fly. Okay. Next I declare another class called sparrow, and it is inheriting another class bird. So it's a concept of inheritance that we just learned before. So here I am writing another method, flight self. Here I am writing print sparrows can fly. Then I am creating another class ostrich. Here also the ostrich is inheriting the class parent class bird. Okay, and here I am writing flight method, and I am printing ostriches cannot fly. And then now I declare objects. So object name is equals to the class name, okay, brackets, and so on for sparrow and ostrich as well. Now I write object name dot intro, the method name. Then it will simply print there are many types of birds. Now I write object bird dot flight. Now object dot bird flight, it will print most of the birds can fly, but some cannot fly. Then I write object sparrow dot flight. Okay, and object sparrow dot intro, there are many types of birds. Object dot flight, sparrows can fly. Okay, it printed sparrows can fly, and not most of the birds can fly, but some cannot fly. Why? It was using inheritance, right? So ideally it should print this flight, isn't it? Let's see in the case of ostrich as well. Object ostrich dot intro, there are many types of birds. Okay, it inherited and it printed this line. Object ostrich dot flight. Here also it is not printing most of the birds can fly but cannot fly, but some cannot fly. It's printing ostriches cannot fly. Why is that so? If it is using inheritance, it should ideally print flight, right? Okay, so let me explain this. So since flight is taking a lot of forms, okay, hence this type of writing flight in different types of forms is called polymorphism. Okay, so this is a concept of polymorphism. But when we are inheriting, okay, when we are using inheritance, the code will first fetch the flight which is first written inside its own class. Okay, so here if I'm printing object of ostrich, it will first find inside its class and see whether I have declared flight or not. If it is declared, okay, if it's already defined inside the class, it will simply print that whatever is written in its class. Okay, but what if I did not write or declare flight inside my ostrich, and I wrote some other method, say eating, and there's no flight method inside ostrich. Okay, there's nothing called flight. And when I'm calling flight, object ostrich dot flight, it will not print anything from inside the class ostrich, because there was no flight method inside the class. So it will directly go to its parent class, and if there is a method called flight inside my parent class, it will simply print that. Okay, so if there was no flight method inside ostrich, it will print the parent flight. Okay. So that was a simple concept of inheritance and polymorphism. Next concept is encapsulation. The word encapsulation, you can see capsule here. So doctors give us capsules like this, right? Inside those we have, the medicine powders and all. What has been encapsulated tightly inside. All those powder and all the medicine stuff has been encapsulated tightly inside that capsule. So this is a basic concept of encapsulation. Encapsulation here in Python is basically encapsulating all my variables and data members, my methods inside a class. We've been using all this while, right? When we write a class, we write all the methods inside the class. We write all the data members inside the class. We write all the variables inside the class, right? So that whole concept is called encapsulation. Okay. So it describes the idea of wrapping data and the methods that work on data within one unit. This puts restrictions on accessing variables and methods directly and can prevent the accidental modification of data. Okay. Next concept is data abstraction. What is it? It is basically hiding internal details and showing functionality. It is known as abstraction. Abstracting something means to give names to things so that the name captures the core of what a function or a whole program does. For example, I have a car. Okay. From the point of view of an automobile engineer, he'll be thinking about the internal implementation of features and functionalities of a car, right? How the internal engine will work, what are the internal parts should be made up of, which metal, right? He'll be thinking from that angle of perspective. Whereas a car user will be thinking from the perspective of his functionalities. What are the necessary features? What are the functionalities of a car? How should I use this car? Will it turn left, right? How should I park the car? How the efficiency of the car, right? So that's the perspective of the car user. Okay, functionality. So basically, similarly, when we apply to a code, when a user interacts with the interface or say the front end, he does not know or does not need to know the functionality or how the code is working at the back end, how it is the data is being fetched and is given to him. He does not need to know all that. He just have to know that when he's putting how to put an input, how to get an output. If he's putting 2 plus 2 inside the computer code, it should give him an accurate result, say 4. That's all the user should know. Does not need to know the complex functionalities behind the code, right? So that is the whole concept of hiding internal details and just showing functionality. This is called data abstraction. So these were the simple and main topics of OOPS in Python. And if you have any more doubts, you can feel free to put it in the comment section below. And if you like the video, like, share and subscribe to our channel eLearners 365. Thank you.